spend it in the evening. So, Joel. Physics.
Physics.
Newton's laws.
Newton's laws?
I have an idea.
Oh no.
Alright, hop off your skateboard a minute.
Alright.
Alright. We're gonna think about Newton's first law, which said that something in motion would stay in motion, or something not in motion would stay still.
Right.
Okay, so if I put this ball on here and I push it towards you,
Yeah.
what do you think will happen with the ball? What do you think will...
I don't know.
Well, my prediction is that it will not travel as fast as the skateboard, so it will look like it's actually going backwards on the skateboard. Alright, do you want to put your hand out and catch it, or do you want me to round your toes?
Go.
Yay! Cool. Alright, and look what happened at the end as well. When you stopped it, the ball ran back. And why was that?
I imagine it's because there's still some force applied on the ball, maybe?
Right, because the motion that the ball had, it had a tendency to continue with that motion without velocity.
Right.
So the sudden unbalanced force of you stopping it reversed that, which is the equal and opposite reaction thing as well. Alright, so I'm going to put this at the front. So look at where the ball is in relation to the skateboard. So it travels to the back of the skateboard and it's got the kick thing at the back, so it sent it back. So, showing that the ball will really want to stay still, even though the skateboard is moving.
Yeah.
Alright, so let's think about the second law, which is acceleration is...
Last time velocity?
No, is force divided by mass. So, let's compare how much acceleration we get with you, as soon as you love,
Oh
in
boy.
the chair. Here, I'll give you a shove on this, and then we'll compare how much you roll with being on a mat.
Here we go.
Alright, so I'm going to stand exactly like this and just use one arm, alright? 1, 2, 3. Okay,
Whee!
so that was a pretty smooth roll, wasn't it?
Yeah, pretty smooth. Oh boy, there we go.
So now I'm going to roll you on the mat that I have under my desk. So, and that will give more friction underneath the wheels. Alright, so
Oh boy.
I don't think you'll roll as far. 1, 2, 3. There you go.
Hi.
That was much slower, wasn't it?
Hi.
Thank you, Mr. Ham. Okay, so that shows us about how friction plays a part, and the acceleration is a result of the net forces acting on you rolling.
Right.
Okay?
Yeah.
Okay, so the third law is about equal and opposite forces, reactions in both directions. So you had an idea about this, didn't you?
Wasn't it that we push each other or each other's third?
Can we have a go?
I guess. Oh boy.
Okay, so what are we going to do? Okay, how about
you
if
turn, you turn around and I just kick
Yeah.
you.
Let's see what happens to you.
Yeah.
So we both push away from each other
Yeah.
with equal
Me further
rolliness.
back because this thing rolls better.
Okay, alright. So that's it on Newton's laws of
Yeah.
physics.
Yeah.
Ciao.
Don't let it.
Okay, so after doing all that mucking around with pushing Joel around on a chair with Newton's laws testing in mind, there was one thing that I wanted to do that I forgot about, so I'm going to do it now. It's I think a really cool thing. All right, so Joel, can you sit in the chair?
Yep.
So I heard about the train observation where a person standing on the bank would see a ball thrown inside the train move in an arc, but the person on the train throwing the ball would experience just throwing it straight up and down. And that kind of blew my mind, because why doesn't the ball go backwards when you throw it? Because once it leaves the person's hand, it should just stay where it is in the air, right? So here's Joel going to be in the moving train, and you can see exactly what I'm talking about. Okay.
Oh boy, here
So
we go.
1, 2, 3. So he's throwing the ball straight up and down, and that actually embodies Newton's law of constant velocity, because the ball is already travelling, and so as it leaves Joel's hand, it keeps travelling forwards, and that's why it travels forwards in that arc and doesn't just travel up and down where it is released from the hand. So let's do that again.
Yeah, this time without me crashing into the corner, please.
Yeah, alright. Okay, so another cool example I heard about of that is dropping a cannonball from the mast of a ship. Like, you would expect the cannonball to not hit the deck, or, you know, in my brain I would have expected not hit in the same spot or be behind the ship because the ship's moved on. But that's not the case, because the ball continues its motion that it already has with the ship. Which kind of makes sense, because if you think about it, we're all moving on this earth all the time anyway, even though we don't feel it. So I just think these are really cool proofs. Okay, that's it. Bye.
Mhm.
1, 2, 3. I think we need to use your chair, it rolls better. Bring the blue chair in.
How, like, if we cut it,
Yeah.
if we cut it, let's have it so, like, when I start sitting down in that chair, then it just cuts to me being the blue chair, just because
Yeah.